Hello, welcome to Pre-Calculus 11. This is Mr. Abbott, and I'll be doing a seminar on Learning Guide 3 and 4, so real numbers, powers, and factoring. All right, let's start with real numbers. So, a long time ago, back in Egypt, when sort of counting numbers originated back in the 3100 BC era. The Egyptians and Mesopotamia, they just had numbers like 1, 2, 3, 4, 5, and those were sort of counting numbers they had. And we know counting numbers also as natural numbers. So 0 wasn't invented and negative numbers weren't invented, so they came a little later. So let's just look at this little chart I have and let's fill it in. Okay, so like I said, the first thing that was invented in the 3100 BC were natural numbers, or we can call them counting numbers, same thing. So they had 1, 2, 3, 4, 5, and so on. All right, then a little later, the Egyptians didn't believe in 0. They thought it was false. So, but in the 3rd BC, in Mesopotamia, 0 came about. So we have a new classification coming in, which is called whole numbers. Now, whole numbers are exactly like counting numbers or natural numbers, but they have now 0. So 0 came in, and then it's 1, 2, 3, 4, and so on. All right, so no decimals, no fractions, no negatives, just 0, 1, 2, 3, 4, 5, 6, and so on. All right, the next classification that came was integers. All right, and integers are the same thing as natural numbers and whole numbers, but they also have the opposites. So 1, its opposite is -1. 2, its opposite is -2. So those numbers came in, and they were first discovered and found in textbooks in China around 200 BC. So integers are like, so -3, -2, -1, 0, 1, 2, 3, so on and so on. So it goes both ways. Okay, then a little later, we classified rational numbers, and we know this as fractions. Okay, so, and fractions, remember, they're also decimals. Because if you have a half, it's 0.5, they're the same thing. So rational numbers are fractions like 2/3, 1/7, -2/5, 0.25, -0.18. So those are all rational numbers. And then the outlier out here, that's not a part of these ones, but it's a real number, is irrational. So irrational are numbers that do not terminate, like the decimal doesn't terminate, and there's no repeating decimal. So the classic example is pi, 3.14, blah, 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 it goes on forever. The square root of 2, if you type that into your calculator, there's no repeating pattern, it never terminates. So those are irrational. Okay, let's just recap now, and let's fill in this chart. So the natural numbers are counting numbers without 0 and negative numbers. Whole numbers include the natural numbers and 0. Integers include all whole numbers and their opposites. So like I said, 2, its opposite is negative 2. Rational numbers are numbers that can be written as a fraction, a over b. And remember, b cannot be 0 because we can't divide by 0. Any rational number can be represented by a terminating or repeating decimal. So like if we have 0.25, it terminates. If we have 1.33333, we write that as 1.3 repeating. So it's a rational number. Irrational numbers are any real numbers that are not rational, which means which do not terminate or repeat. Okay. All right, let's look at topic 2 now. Topic 2, we're going to get into roots and radicals. So just to refresh, this guy right here, this sort of fancy looking sign is called a radical sign or a root sign. Now it's made up of different components. We have an index, which is a number up here. We have the radicand, which is the number underneath, and the whole thing is called a radical. All right. So the first thing we want to do in example 1 is write from rational exponents to radical form. Okay, so if I have this example, 5 to the power of 2/3, we just have to remember a couple things. The denominator of the index goes there, of the power. The numerator of the power goes outside, and then this is the radicand. So it's pretty straightforward. And you can write it either way, it doesn't really matter. You can have a 2 outside the bracket or you can put it in there. Because if you evaluate it, you'll get the same outcome. So you can pause this and try these examples and then come back and check. Okay, so there's the answers. Now, this one here, I'll just watch out. This negative sign is not included. See how this negative is not included? So it's outside. So watch out, I just made a little boo-boo there. So make sure you do not put it inside because it's not included in the bracket. All right. And this one, because you got the negative there, you have it's 1 over. So watch out for those ones. Okay, now we're going to go the other direction. We're going to go from the radical form to the exponent form. So again, you can pause and then you can check your answers. Okay, so again, this one was pretty straightforward. This one you got to watch out because there's no index there. So if there's no index, we know it's a 2 because it's a square root. So just watch out for that guy right there, that 2. And this one had the 1, that's why I added the negative sign. Okay, example 3 is we're going to evaluate. So when you evaluate, you take this guy and just write it out in form. So there's the form. And then what I did is I just did the bracket first to get 2, because the cube root of 8 is 2, and then I squared it to get 4. So these ones, you have the 4th root of 16, which is 2, and then you have the square root of 144, which is 12, minus the cube root of 27, which is 3. So the answer is 9. And this one here, you have the square root of 81, which is 9. And then you have 9 times 9 times 9, which is 729. And now here you have a 6th root of 64 to the 7th. Well, the 6th root of that is 2, and 2 to the 7th is 128.